Hello everyone. Today we will be working on making infographics in R. So for starters, you're going to want to pull up your data set. So we're going to go over to Import Dataset from Excel, browse, and go through my complicated series of folders. Hopefully quickly finding the data that we need. Documents. Be a whole lot easier if I just took it out of the folders, but gotta stay organized. So I'm going to use lesson 26 data file 1 prime. Going to bring that into R, and it's going to code preview library read Excel to actually allow it to read Excel. Lesson 26 data file 1 prime will be pushed from the read Excel file and what is found in my computer, and it will be seen as view lesson 26 data file prime. And here's just a quick preview of it. This is the data set that I'm going to be using. Focuses on gender test note-taking methods, and GPA improvement. So back into the actual syntax. We're going to start with define parameters, and we're going to push parameter no read-only equals true. So this pretty much sets graphical parameters, and only parameters which are returned can be set by a subsequent parameter called on the same device. So basically, this line allows us to add specific parameters to each of the charts that we want to make, and it'll push all of it into define parameter, which eventually we're going to print out on a separate PDF to give to the client. So for starters, library read Excel, we already went over that, and we're going to attach the lesson 26 data file 1 prime to our actual data set. So we're going to take lesson 26 data file 1 prime, and because I don't like repeating that over and over again for the many times that I'm going to have to use it, we're just going to push it into simplified data. And so we're going to run this section real quick just so R has data to work with, and as you can see, it appears over here with the same number of observations and variables. So for starters, we're going to want to figure out how we want our infographic to look. So that's what this part is over here, our layout matrix. So layout will determine basically what the infographic will look like, and so we want a matrix, and C will combine the values into a vector or list. So I'm going to come back to these in a moment after I go over the shape of our matrix. So we want a 2 by 2 matrix. 2 rows and 2 columns. So that's what these 2's correspond to. By row equals false basically corresponds with the orientation of how the following plots will appear in the infographic. So if by row would equal true, then the largest box, the one that's would be horizontal. So our histogram, our bar plot is supposed to be the largest one, taking up 2 spaces. We'll get to that in a moment, but since by row is false, it'll orient itself vertically in a column rather than being by row, so not horizontally. So back to the 3312. It's not some secret code. It actually corresponds with the 3 different plots we've chosen. So the order that they're in corresponds with the order that they will appear in the matrix. So this is 1, this is 2, this is 3, this is 4. These are the spots. So since we want our bar plot to take up spaces 1 and 2, we're going to put the corresponding number in the first and second plot. So we've told R that we want a matrix that's 2 by 2, and that we want to put the third chart, which is our bar plot, so first, second, third, into this spot. Now, the 1 corresponds with our histogram. We want that in our top right, third spot. And number 2 corresponds with our density plot, and we want that in the bottom right, our fourth spot. So that's how our infographic is going to look when we run it. So next, we're going to run our entire histogram so that we have a visual reference of what we're doing. And as you can see, after I've run it, there's that whole big bar plot section missing, but that's because the window isn't done running yet. The code isn't done running yet. So this stop indicates, hey, there's still something that you need to do, and it's the legend locator from our density plot. So we're going to just go ahead and throw that in there for now. Pop that in. So after we put that in, it gives us the rest of the chart, and you notice that the stop has disappeared. So going through each of the plots, we'll just start with the one that appears first. We have our histogram. Before we get to our histogram, we've actually defined parameters for a specific margin. So that's what this par mar is. Excuse me. So we've set margins that will correspond with the part of the plane that they're in, basically. We don't want our graphs overlapping, and we don't want them too stretched out in any direction. So the numbers 4422 correspond with specific directions. So the first one is the bottom, the second one is the left, the third one is the top, and the fourth one is the right. So BLTR is a useful acronym that I've learned for them, and the C, once again, combines the values into a vector or list. So by changing these values, you can change essentially the margins of the graph. So if these were larger numbers, it would stretch the graph out further left and bottom. The 4 is what I'm referring to. If the 2s were smaller, they would stretch the graphs inward more. So 4422 keeps it tight but also visible. So not too small, not too large. So that's why I went with those numbers. So now making the actual histogram over here, we have histogram going into the data set and using the $sign. It's basically a claw machine. What are you telling it to go in and grab? So we want to grab the variable GPA improvement. Breaks are essentially the distance between the different sections in the histogram. So the larger the break, the more spread out that the histogram pieces will be. I settled on 7.5 because 10 was too far apart and 5 didn't show enough variability, so 7.5 was a decent size. Y label labels our y-axis. Number of students corresponds over here. It's important that it's in the parentheses. X label, GPA improvement, is our label for our x-axis. And main is the student GPA improvement. It's our main title. We also wanted to make sure that this chart and this chart had the same horizontal length as well as numbers. So we set an X limitation to have the smallest amount, which is -0.2, and the largest amount, 1.12. And so this sets these values down here. Moving on, similar par mar with the exact same output numbers for our density plot, which is right here. So moving through, we want to make a new variable, method.f, to use later in the plot, because we need to make a legend. So in order to make a legend, we need to make a new variable. So we're going to push some things into method.f. So we're going to make a factor of go in to this data set, the lesson 26, and grab the variable method. And that variable will have levels that we're going to define, and we want you to define them in this order, 1, 2, 3, 4. These are the number of levels that it has. Those levels are going to correspond with these labels, and we're going to label them accordingly. Method 1, Method 2, Method 3, and Control. So we're going to push all this into this variable and then just hold on to it. So next we're going to make the actual plot. That's what smDensity.compare does. Makes a density comparison plot. So once again, data, go in and grab GPA improvement variable, comma, data, go in and grab the method variable. So we want to use it to get the GPA improvement for our actual x-axis, and so we want to label that with our xlabel command. And once again, we're setting our x limitations the same as the histogram. That's why these numbers appear as they do. The y labels can't be the same because the y's are measuring two different things, density and number of students. So moving on, we set the title with title command, and main title equals student GPA improvement by method, and then we want to build a legend. So we have the legend command, locator, which allows us to choose a specific spot to press it. You saw me moving around before. 1 is the type. Levels, or is the number of legends that we want to put in. Levels, method F, so these are the levels of the IV that we want to plug into our legend. So you see method F again appearing. And then fill, so we want the colors to actually correspond with the colors that appear on lines, because if your legend doesn't match, what's the point of having it? You don't know what your graph's actually showing you. So we used the C command once again, and 3, 2, 4, and 5 correspond with green, red, blue, and light blue. And these are all commands found in the help viewer for colors. So moving on, we're going back to parameter and margins, using the same parameters and margins for the bar plot so that it's visible but not overly taking up most of the screen. It has an equal visibility as the other graphs. So we're going to do just simple bar plot, and we want table to make the table, and go into the dataset, grab method omega, which is a specific different variable from the previous method variables, main, which will give us the title, method preference of respondents, so that we know that what we're looking at is which methods were preferred by which respondents and how many. So our X label is the number of respondents, and our Y label is actually the method preference. Oops, these are switched. So now that these are fixed with the appropriate labels, so method preference is where it's supposed to be between 1, 2, 3 and control, and Y label is the actual number of respondents, which is how the graph is supposed to look, we can just make that graph with the marginal parameters that we have set. The last step is to export it essentially into a PDF document. So we're going to use dev print, which basically copies the graph to a new device, and we're going to set that device as a PDF and tell it where to put it. So going through all my folders to save it as a PDF, and we're going to end with parameter define parameter. So it basically just reuses this up here and saves everything into this new PDF file. So we're going to take everything and we're going to run it all. We set where we want our legend to be, and now this will be saved as a PDF, assignment 3 chart prime.pdf. So we're going to go and open it. Home. Desktop, because we saved it in the desktop for convenience sake. Assignment 3 chart prime, open that up. So there's our chart, but we need an actual report to mix it with. So I've elected to use pdfmerge.com so that you can choose a file and merge two PDFs. There are many different ways to go about doing this. I found this to be the easiest way, since you have to actually pay for the Adobe Pro to merge PDFs within the software. So choosing the files in the order that you want them to, I actually already did the write-up. Boop, boop. make sure that they're in, and you merge them, and it actually appears as a download.